Hi again, everyone. Chris Tisdell here again. Thanks for tuning in. In this presentation, I am going to continue my series of videos on calculus, and I'm going to show you a couple of ways to compute partial derivatives of functions. Now, I'll show you a quick way where you can avoid using the chain rule and just do the differentiation straight up. And I'll also show you an example involving the product rule for partial derivatives. So let me share my screen with you and we can get down to business. Here is the example we're going to look at. We've got a function of two variables here. Oh, let me move that over. That's a function of two variables. And we're asked to do two things. We're asked to calculate this partial derivative and this second order partial derivative. Now, just remember the curly D's means partial derivative, in this case of z with respect to the x variable. Here we're talking about a second order mixed partial derivative, and essentially you compute these derivatives by holding one of the variables fixed and just differentiating normally. So how do we do that? Well, let's try the first problem where we were asked to calculate dz dx. Okay, now we've got sort of two functions here. We've got a cosine function and an x squared times y function. So this whole right-hand side, or the middle bit, is kind of like a function of a function here. So this is a composite function. And, you know, technically speaking, you could apply the chain rule here. But it's a pretty simple function, and you can do it without the chain rule. So let me show you what we do here to save a bit of time. Also, I have other videos on the chain rule. So let's consider the following. So let's consider the derivative. So this just means I'm about to take the partial derivative of this function with respect to x. Now, when we do this, we imagine y is a constant and we just differentiate normally with respect to x. So imagine y was 2, okay? The 2 would come to the front, the derivative of x squared would come to the front, and the cosine would become a negative sign. So let's unpack that a little bit. For this particular example, what you want to do is look inside the brackets, compute the partial derivative with respect to x. Okay, so if I imagine, forget about the cosine, imagine y is a constant. The derivative of this with respect to x is 2xy. That comes to the front, and then you multiply by the derivative of the cosine function. Okay, what's the derivative of the cosine function? Negative sign. So let's do that. So we take the derivative of what's in the brackets with respect to x, it's 2xy, and we multiply by the derivative of the cosine function. The cosine derivative of cosine is negative sign. Okay, so there we go. Now let's just move that out there and tidy it up a bit, and we'll get the following. Okay, so that was pretty easy. I didn't need a chain rule. You could just do it by looking at it. Let's do the second problem. Now, by the way, I do have other videos on the chain rule justifying these kinds of steps. Okay, so the second question is compute this second order partial derivative. So here I computed dz dx. Now I want d dy of dz dx. Okay. So let's consider dy of dz dx. So that means we've taken the partial derivative of z with respect to x, and now we're about to do it with respect to y. Take the partial derivative of this with respect to y. Now I can get this from up here, of course. This is dz dx. So it's just okay. So what do we do now? Well, you can see here we've kind of got still this function of a function, but we've got another function multiplying through by that function. So this function times this function is what we're interested in. Okay. Now, just like there's a product rule for regular differentiation, there's also a product rule for partial derivatives. So let's unpack that a bit. So we will take the derivative of this with respect to y times this function plus the derivative of this with respect to y times this function. That's how the product rule works. And it's the same for these partial derivatives. Okay? So let's do that. So the derivative of this, if I differentiate negative 2xy with respect to y, I imagine the x is a fixed, and differentiate with respect to y, I'll get negative 2x, and I times that by the other function. And now I need to multiply this function by the derivative of this. Now, again, we can save time. If I want to compute d dy of this, the derivative with respect to y comes to the front from in the bracket, so that'll become x squared, and the sign goes to cosine. So I'll get an x squared out the front, and I'll be multiplying by cosine x squared y. So let's pretty this up a bit, and we're finished. So those x's can be combined. All right. So let's make a conclusion or write down the final answer. Okay, so we've got all that. Let's combine this. So dz dx will be this. D squared z dy dx will be this. So let's actually write that down. Okay, there we go. There you have it. Pretty simple. Okay, you could argue that yes, you should use the chain rule there. I don't think it's necessary. You're kind of using a sledgehammer to crack a nut, and I have other videos on the chain rule as well. And just remember, the partial derivative gives us the rate of change in a function with respect to one variable while the other variable is fixed, and you can relate it back to slopes of tangent lines. Okay, I hope you found this presentation useful. Again, I've tried to optimize this presentation for a mobile device. That's why the font is huge. So if you're watching on a mobile phone, let me know your comments. Thanks for watching. Bye.